Us. Today we will read about the rock cycle. So in last class, I have discussed about interior of the earth, that all division and classifications, chemical division, physical division, study of seismic waves, everything I discussed in the last class. So here what is first one, rock and mineral difference. We know element, single compounds. Then these elements together will form, you can say, kind of compounds, that is mineral, and these minerals together form rock. So rock is the aggregate of mineral. Rock is the aggregate of mineral. Rock is aggregate of mineral, means a group of mineral elements, you can say. Aggregate means group. Whereas minerals are solid inorganic substances occurring naturally. Even rocks also occurring naturally. So rock doesn't have definite chemical composition, doesn't have definite, because they are mixing many different minerals, but minerals will have definite. For example, limestone you take will have calcium carbonate. So minerals are organized to form rocks. Here elements are organized to form rocks. Elements are organized to form rocks. Three chief types of rocks, very important: igneous rocks, sedimentary rocks, metamorphic rocks. These are the three most important types of rocks: igneous rocks, sedimentary rocks, and metamorphic rocks. If you see here, example: basalt, granite, sandstone, slate, quartz. These are the important types of rocks. For chief mineral groups are silicates, carbonates, sulfides, and metallic minerals, iron, silicon, etc. You just remember basic idea: what is element, what is mineral, what is rock. That's all. You don't need to remember all these points. So rock is aggregate of mineral. Mineral is aggregate of, you can say, it is solid inorganic substance composing a group or compounds of elements. Then feldspar. Feldspar and quartz are the most common minerals you can find. And the scientific study of rocks is called petrology. This is important. What is petrology? Scientific study of rocks. What are the most common means? Feldspar and quartz are the most common minerals found in the rocks. There are two types of rocks based on the presence of the acid forming radical, that is silicon. Based on silicon, we have two types of rocks. One is acidic rocks. One is acidic rocks. Second one is basic rocks. Acidic rocks means there is granite, quartz, feldspar. Example you remember. And basic means basalt, gabbro, dolerite. So acidic means here silica will be more. Acidic means silica will be more. Greater silica. Silica is more. Can you remember here? Acidic means silica more. Silica is good. Silica more means, I told, it is less dense. Silica more means less denser. I discussed it in last class. Silica more means less denser. Then basic rocks. So these are heavy, these are dense rocks. So here silica is less. Yes. These are dense rocks. So the proportion of silica in rocks is a major factor in determining their property or names. Proportion of silica. This is also one of the exams they asked. Which of the following is uh, based for the classification? So this is the silica is the component we taking into account. Then three types of rocks. These are important, we have to study. So first one is igneous rocks, then sedimentary, then metamorphic rocks. So igneous rocks, sedimentary rocks, metamorphic rocks. These are three most important, and these important questions are coming in various exams from this topic, including the SSC exam. So igneous means a fire. Here magma is coming from inside the earth. We know here there is asthenosphere. I discussed asthenosphere. So here magma or lava is there. This is actually coming like this, and sometimes it will hit the plate, that is earth. What we say lithosphere. lithosphere. This lithosphere I discussed last class. So when it is hitting this magma, rising magma hitting this earth, this lithosphere, this will breaking and the lava is coming. This magma when it is coming out, we calling it as lava. So like this it is coming and it is settling here. This lava is coming and settling here. Sometimes what happens, this lava is settling below the earth only. Okay. So here what happens, when volcano is there, okay, when volcano is, for example, like this magma is coming outside and settling here. Sometimes it is settling in depth only. Sometimes it is settling just below. So these are three types actually. So these types of rocks we call plutonic rocks. Plutonic rocks, and just below the surface we call hype abyssal rocks. Hype abyssal. Hype means just under. Hype means under, just under the surface. And this upper surface, on the surface, these are called, we call this as volcanic rocks. Volcanic rocks. So below surface and above surface. Above surface only one volcanic rock. Below surface we have hype abyssal and plutonic rocks. These two together we call intrusive igneous rocks. IR means igneous rocks, intrusive. This volcanic rocks we call extrusive. Extrusive means outside the surface, earth, inside, interior of the earth. Intrusive means below surface. Extrusive means above surface. So here various rocks are forming. For example, here plutonic rocks, we say this is granite. Example, this is granite, plutonic rock. And hypabyssal rock, example 1, you remember? 1 minute. Dolerite. And volcanic rocks, you can remember, this also having actually split up. We will see. This we have explosive eruption and a quiet eruption. Explosive, quiet eruption. So quiet eruption will come basalt. In explosive, that ash, volcanic bombs, we say rocks. Okay, we say that is volcanic bomb. Some big rocks are coming and it is the vent through the volcano is throwing out. That is eruption. Quiet eruption is basalt. So this classification is quite confusing. This is important to note actually. So what is happening here? I will just repeat it. So igneous rocks means just lava coming out and just that is forming rocks. That is igneous rocks. We call this as a primary rock because the lava, it is first time it is forming the rock, right? Directly rock coming from the lava. So this is the primary rock. This is the primary rock. So I repeat this same process here. So this is surface. Here when lava is coming, sometimes it is settling here only and forming the rocks. These are plutonic rocks. Sometimes it is just below the surface it is settling. These are hypabyssal. These two together we call what rocks? These two together we call intrusive rocks. Intrusive means inside, you can say. And some lava is coming and here reaching the surface and forming. Some are thrown out like big rocks, you can say. These are volcanic bombs. These are explosive, we say. Explosive eruption, we say. Erupt means coming out. Erupt means coming out. Erupt. So explosive eruption. Explosive means it will make big noise kind of thing and with sound it is coming. That is explosive, noisy. And there is some other type, some quiet eruption, like quietly it will come and it will form rocks. Okay, quiet eruption. This example is basalt. Example is basalt, and there is another rock, andesite. Okay, andesite. And there is plutonic rock. This Example very important, granite. And another example you can say gabbro. And hypabyssal example dolomite. They will ask example. For example, now I will frame question here. Which is the in-depth igneous rock? You can say rock that form igneous. Which of the following? They give granite, basalt, dolerite like that. So granite is at in-depth forming, at depth. So just below surface, which of the following rock? Dolerite. They give dolerite option, or they will give name also. What are hypabyssal rocks? Just hypo means under, just below the surface it is forming. Plutonic means very depth, in depth it is forming. Outside on the surface, two. One is explosive, white. Explosive means, for example, big ash, volcanic rocks are coming, volcanic bombs we say. Another one, quiet eruption, that is basalt. Example important, basalt is important. And this explosive and quiet eruption, these together we call volcanic rocks or extrusive rocks. So what is igneous rock first? It is coming forming directly from the magma. Magma just is coming outside and it is cooling down and it is just forming as a rock. It is also called as a primary rock. So these are two types of igneous rocks are there. One is below surface, that is intrusive. One is above surface, that is extrusive. So intrusive means within, below the surface. Again intrusive to somewhat depth, plutonic rock. Example granite, gabbro. Just below the surface, hypabyssal rocks. Example dolerite. Extrusive rocks, two types. Explosive, make more noise. That is, example is volcanic rocks, you can say. Volcanic bombs, we say. Big rocks are throwing out from the volcano. And there is quite eruptions like basalt, it is a rock. So here one thing you have to understand, this concept is important to answer the questions actually. If you understand concept, you don't need to remember, you will answer the question logically. For example, here you listen, when here here actually this plutonic rock is there. Okay, here the lava is coming, this magma, sorry. When magma, when below the surface we call it is magma. So when magma is coming like this and it is settling here only because it is having less energy, means it is less hot. More hot means it is more heat, means more energy it is having. Because it is settling down only, it is having less energy. It is not having that energy to just break the lithosphere and come outside. No, it is not having that much energy. It is having just a little energy to support, just to little, uh, at below depth only it is settling. It is having less energy, you can say. So then here it will settling at the depth. So when it is settling at the depth, it is what happens, it will take time to cool it. It will take time to cool, because for example one volcano, is magma is coming and settling outside. Here there is heat, it can go surrounding more fast, it can cool very fast. But here it cannot cool, it can cool slowly. So here big crystals like will form here, crystals. So for example, granite will have big crystals it will have. So this is a coarse grain, you can say, coarse grain, big crystals. So this thing you have to remember. So big crystals will form here. Whereas if you to go above, it will cool very fast. It will have very fine grain. It will not have crystals. For example, basalt, it is very glassy. It will break easy. It is not that strong, you can say. Whereas granite is very strong, very, it will give very strength. That crystals will give very strength to this. So this is a very important concept actually. These types of magma is there one topic that we will see later. Okay, let me just erase this one. Here type of magma is there. Types of magma I will discuss later. Otherwise, let me discuss here only because this is important. We have to understand various magmas are there. In magma also various types are there. So first here, granitic magma I told. So granitic magma here, what will happen? It is a high silica magma. High silica above 66% magma. High silica means it is having less dense. So magma low density. So low density means low temperature, low energy. That's why it is settling at depth only. So here you see when magma erupts, so higher chances it cools below the surface. It cools below the surface. Here temperature is less. If magma cools below the surface of the earth, rocks formed are called intrusive igneous rocks. Whereas basaltic magma, here low silica content. Basaltic low silica content. So it will have very dense, that is magnesium, etc., iron, etc. So here silica below 52. Below 52. So below 52 basaltic magma. It will have higher density, so higher temperature. Basaltic magma, basalt, which forms the basalt rocks. It is definitely extrusive igneous rocks. It is forming. It is coming out. It is cooling very fast also. So no crystals it will form. This is important. No crystals. Here crystals are forming, and then in between it is also there. In between, so not that high, that low. So these are also Andes. You will find in Andes mountains. These are also mostly. It will also mostly erupts. So granitic magma, basaltic magma, I remember. Granitic magma, greater silica, I remember. Above 66%. So it is less dense, low energy. So it cannot have that energy to erupt out of the surface. Whereas basaltic magma is there. It is having less silica, but having more dense, heavy. So greater energy it is having. So it can just break the lithosphere and come out and form basalt rocks. So these are the two type you remember. And we call granitic magma as felsic. Silica means I told light, magnesium heavy dense. This we discussed in last class also. Felsic rocks, mafic rocks. For example, felsic rocks light we will find in continental crust, whereas mafic magnesium we find in oceanic crust. These two together form crust. Continental crust, oceanic crust. We have magnesium, so oceanic crust is denser. Oceanic crust is denser. So these characteristics I told already to you. You just listen. Intrusive igneous rocks. These are called plutonic rocks. So these are slower cooling because they are not coming outside. They are below the surface only. Cools below the surface. They are crystalline in nature. Means they form crystals. TLS. They form crystals. So that's why they are hotter, stronger because they are taking more time to cool. So for example, granite it is very strong. We are using for construction. And depending on the depth, we have deep below the surface, we have plutonic rock. Example, granite. Near surface, we have hypabyssal rock. These are also called dike rocks or intermediate rocks or semi-crystalline in nature. These are example dolerite. Why semi-crystalline? It is forming near surface, so it will cool somewhat faster than the granite because granite is still more depth. It is in depth. So these are all called intermediate because it is forming just below surface. Here plutonic rocks are there. Here basalt and other rocks are there. So in between intermediate. So this is hypabyssal rock. So now extrusive means outside the surface. These are also called volcanic rocks. Very important. These are also called volcanic rocks. So they are coming outside the surface. So faster cooling. Cool above the earth surface they are coming. Have uniform and glassy texture. So they are not that strength, lower strength. Nobody uses basalt for the construction. The house will collapse like that. Now types of extrusive igneous rocks. Explosive, quiet eruption. Explosive eruption erupt out throughout near volcano, volcanic bombs, for example stones. There is pyroclast material, mix of that fired material, fragments of rocks, all that. Then coet eruption, rocks formed due to coet eruption. Basalt, andesite, and then pumice also one type of coet eruption rock, igneous rock, coet eruption, igneous rock. Then characteristics of primary rocks very important. They do not contain any fossil, for example. What is the fossil? Any animal or plant material that is there now in the form like coal or petroleum, natural gas, like that. But if you see that much fire or that much magma is coming, these fossils will get destroyed. This, for example, coal is there. When magma is coming, that coal will be automatically destroyed. So they do not contain any fossils. So fossils are there only in one type of rock, very important, sedimentary rock. For example, coal, it is a fossil fuel. It is a sedimentary rock. For example, natural gas from sedimentary rocks we are taking. Shale, okay, there is shale also. Shale also sedimentary rock. We will see this sedimentary rock later. So they do not contain fossil fuel. If any fossil fuel is there, no chance at all. And they do not contain layers or strata. Strata means layer, you can say. Layer means, for example, like one layer, then another layer, then another layer. Like this, it is no. Volcanic rock or this igneous rocks, no layer will be there. No layer. And this no need to remember. And you remember this is important. 65% of the earth crust is the igneous rock. 65%. So igneous rock, 65% igneous rock. Then 27% is the, you remember, 7, almost 8% is the sedimentary rock. Then 27% is the metamorphic rock. This is important. This is asked in various exams. So 65% of earth crust is the igneous rocks. 8% is the sedimentary rocks. 27 is the metamorphic rocks. Metamorphic rocks. So if you take 65% are igneous rocks. Okay. In this igneous rocks, 66% are basalt. Like outside quiet eruption and they're forming. So 66% is the basalt and gabbro. Gabbro is the plutonic rock. Depth, in depth. It is on the surface, quiet eruption. Basalt. So 16% granite and 17% granite diorite and diorite. So diorite also igneous rock, you remember. Then 0.6 syenite and 0.3 ultramafic. Next you remember oceanic crust is 99% basalt. Oceanic crust is 99% basalt. And granite all that dominate the continental crust. Why? I told continental crust will have lighter material. Granite is lighter now. So granite you can say like that logical. So ocean crust basalt. Basalt is denser. That's why it could come out, magma can come out and form basalt. So what you have to remember? When magma, here in depth one forming rocks, near surface one rocks, outside surface one rocks. Slow cooling, somewhat faster cooling. This is very fast cooling. So here big crystals will form. Crystals. Here semi, here no crystals. This is fine grain. This is coarse grain. So they will ask you, granite is the fine grain or coarse grain. Which of the following is coarse grain rock? Then granite can be the answer. Fine grain, basalt can be the answer. So here I explained further. Extrusive rocks means outside on the surface are formed from quickly cooled lava flows on the surface. Quickly cooled, it will cool quickly on the surface, not from slow cooling. The rapid cooling prevents the formation of larger crystals. That is important. So resulting in the fine grained texture. Fine grained texture. So igneous rocks is very somewhat confusing. So remember igneous rocks, there are two types actually. below surface, above surface, like that. Below surface, above surface. So like that, you remember. You just see and go through again if you don't understand that. Now, now come to sedimentary rocks. Sedimentary rocks. Sedimentary rocks. What happens actually here? Uh, for example, one rock is there. So this will keep breakdown here. This is what weathering we call, and this transported to various distances, and wherever depth is there, it will go and settle. Okay, like this you can say, will go and settle. For example, one tree is there, so this tree and will settle. Some animals also will settle. So some layers like this will form, and over a period it will be get compressed, and it can be formed as a rock. Okay, this is what we call sedimentary rock. Sediments means it is a broken fragments of the rock. They keep coming and they are keep layer by layer settling down. So here there is the process first. Here weathering is there. That is breakdown of the rock like this. Then transported to lower parts and then deposit here. Then lithification means here becoming of rock. For example, these layers will over a time will try to condense and form like a rock. Then compaction means like becoming still smaller, and then cementation means any gaps are there, that those gaps will also be filled. So here this is layer by layer will form, and here we have fossils like maybe sometime plants, animals. They also killed animals also they are coming and forming as a layer by layer. That is where we find a fossil fuel in sedimentary rocks. Okay, fossils. That's why we find. So this is weathering is there, transportation, deposition, and this lithification will be undergoing, becoming rock, and then compaction, then cementation means becoming those gaps will be filled. Then sometimes even diagenesis, one process you remember simply. Diagenesis means some recrystallization will happen, some arrangement will happen. Okay, some alteration of arrangement, mineral alteration. That is diagenesis. That is after cementation, you can say. Then characteristics, it is forming layer by layer. It contains fossils, largest by area. If you take this is the earth, largest by area, almost 70-80%. This is formed, but only 7% by volume. Only 7% by volume. Okay, that is there. Then this is the thinnest layer. Okay, compared to this is a high porosity, high permeability. These are reserves of minerals and fossil fuels. So these are all important characteristics. Then you remember mechanically formed types. Mechanically formed means by some action. Sandstone conglomerate, limestone, shale, and loess. Organically means biologically, you can say. Geyserite, chalk, and limestone coal. Chemically formed chert and potash, limestone, and halite. They are depending on formation. Then clast means a fragment of rock. Then quartz is there. It is a sedimentary rock. Quartz is very important. Is resistant to weathering. Fine grained rock, basalt I told already, fine grained, andesite also. Coarse grained, which is granite or gneiss. Gneiss is a metamorphic rock, we will see. Then this size you remember, which is one. So clay is the lowest one. So pebbles, gravels, then sand, silt, clay. Okay, boulder means very very big. Cobble means somewhat less. Pebbles means like this. Gravels means some no shape will be there. Okay, like that. Round means pebble. Otherwise gravel. Then sand, silt, clay. Okay, this classification you remember. Which size first will come. Then example of sedimentary rocks. Just remember the names. That's all. So there is conglomerate. There is breccia. And there is sandstone. In sandstone also we have quartz sandstone, arkose, lithic sandstone, quartzite whack or lithic whack, feldspathic whack or grey whack. So sandstone and its types. Just remember names. And there is mud rock also, clastic rock. These are all clastic sedimentary rocks. Clastic means mineral origin. Okay, for example, mud rock also, which composing silt and clay. So claystone means clay will be there more, then shale, then mudstone, then mud rocks. Okay, mud rocks form very low energy. So mud rock, they simply ask mud rock is what, like it is what, sedimentary or igneous, like that. Then silt, from silt it will form siltstone. And shale I already told you. Shale I already told. Then non-clastic sedimentary rock. Non-clastic means not mineral origin. So here mainly remember limestone or chalk. Then dolomite also a type of limestone. Then chert. Then evaporates like gypsum. Okay, like halite, gypsum. Remember mainly gypsum. Gypsum also sedimentary rock. Then rock salt will come. Rock gypsum. Then coal, very important. Coal is also a sedimentary rock. So about 7.9%. So almost 8% by volume. It is composed. These are also called stratified rocks that you remember, or detritus rocks or aqueous rocks. Then metamorphic means you apply high heat and high pressure. It is change in form, metamorph, change in form. Under high temperature, under high pressure, anything, whether it is igneous rock or metamorphic rock or igneous rock or metamorphic or sedimentary, whatever, igneous, sedimentary, metamorphic. These rocks, if I go under high temperature and high pressure, okay, high temperature, high pressure, they will go under metamorphism. Okay, process change one metamorphic rock into other metamorphic rock is remetamorphism. This increases strength. So because high temperature, high pressure we are applying. So whether fossils will be there? No. Fossils will be gone. This is important. Fossils will be gone. That is what it is their point. So now this example you remember. Granite becomes gneiss. Sandstone becomes quartzite. Limestone becomes marble. Shale becomes schist. Coal becomes graphite and diamond. So these are the examples. Here granite is igneous rock. When we apply high pressure, it will convert to gneiss. Sandstone is a sedimentary. It is converted to quartz when you apply high temperature pressure. So here you don't think granite is the sedimentary rock, no, or metamorphic, no. Here gneiss is the metamorphic rock. Here quartz is the metamorphic rock. Marble is the metamorphic. Shale becomes schist is the metamorphic rock. Shale is sedimentary. Limestone is sedimentary. Sandstone is sedimentary. Granite is igneous. Coal is sedimentary. It is becoming graphite and diamond when you apply high temperature and pressure. So their physical property, their chemistry changing. Okay, recrystallization is happening when you apply high temperature and pressure. When you apply high temperature pressure, recrystallization happening. So 27.4% I already told. Then types you remember, contact metamorphism means when magma is coming in contact with some rocks, there is contact metamorphism. Burial means under pressure. So let's say this is earth in very depth it is having. Then regional means, for example, one hilly mountain folding is there, folding. When okay, then regional big area, regional metamorphism. Contact metamorphism, burial metamorphism, regional metamorphism. Okay, so this is high temperature, this is high pressure, this is high temperature plus pressure. Large scale metamorphism. Temperature will be there, pressure will be there. Then foliated, non-foliated, simply remember the example. Foliated means layer by layer, you can say like that. Okay, foliated, non-foliated. Then rock cycle means conversion of from, for example, igneous rock, sedimentary rock, metamorphic rock. So igneous will convert into like this too, and this will be like this. Okay, and this is converted into this too, like that. So one rock will be keep converting into another rock. This is rock cycle. One rock is not, for example, igneous rock. Igneous rock is coming over a time. You apply temperature, pressure. It is converting into metamorphic rock. For example, one metamorphic rock is there or igneous rock is there. Here, whatever eroded material it go on keeping a deposit and it will form sedimentary rock over a period. So one rock keep converting into other rocks. So that is the what rock cycle. Rock cycle. So this is important. Thank you. You just revise once. I told somewhat very fast. So you just revise. Only facts are there. Concept I told. You just remember these facts. You can easily answer all the questions in this topic. Thank you.